But you got to think, Euler's in the 1600s here. It's not like he could flip on the TV, watch a movie, play a video game. Yeah, but you also have to understand somebody this mathematically brilliant, they can't stop thinking it. It's just, and it's like a puzzle, and they get absorbed in it. So, in fact, this Euler, in the last 10, 15 years of his life, he went blind. And so then he just hired an assistant to write down the math, and he did it in his head. Yeah, I can't imagine, keeping track of where you were mentally. He had to be able to mentally see the problems or something, whatever he was doing. Yeah. So yeah, imagine doing it all in your head all the time. So we're talking extreme brilliance here. But and I don't know the history of why he was playing around with this particular formula. He was a lot interested in what happens when things go off to infinity. So I'm guessing that's where this was leading. But how he came up with this exact formula, I'm not quite sure. But yeah, he was playing around with it and was looking for patterns and started asking the question, okay, what do you get if n's 1? So if I put 1 in there, 1 plus 1 to the first is 2. Because 1 plus 1 is 2. And so then he said, all right, well, what happens if I put 2 in?
4.
Nope. That'd be 1.5 squared. Yeah. It's 9/4 or 2.25. If you think of 1.5 squared, 1.5 squared is 2.25. So, okay, it got bigger. But then, and you're not going to probably want to figure these out unless you have a calculator in hand, if he went up to 3s, and granted I'm rounding these off now, it goes to 2.37. And then he threw 4 in, and it went to 2.44. Do you see any pattern? Is it going up by a steady amount every time? Nope. It goes up by 2.25. I could write that here sometime. And then it's going to go up by 0.12. And then now it's only going up by 0.07. It does always 2 point something, yeah. But what do you notice about how much it's going up? It's decreasing. It's smaller. So every time you go up, every time we increase it to a higher number, it's going to go up a little, but it's going up a smaller and smaller amount. So if it's going up, eventually it's going to be going up teeny tiny, itty bitty decimals, 0.000000012, something way out there. So eventually it starts to home in on a value. If you put n as 100 or 1,000, then it starts. You start to see the same decimals repeated over and over. And it actually turns out, if you let n go off to infinity, if you let it get so large, and this has actually been proven, it comes out to be, and once again I'm rounding it off, 2.718 is the number we work with. It's actually just like pi, it's irrational, it goes forever, it doesn't terminate, it doesn't repeat, but that's the short value. Just like you guys do pi as 3.14, if you need to throw it in as a decimal, we do E as 2.718. So he found out that this was going to come out to be 2.718. He did not name it the number E. In fact, I don't know if he actually, in his lifetime, he knew it was a significant number. I don't know if he actually ever lived long enough to realize how significant E was going to become. I think other mathematicians, probably after his death, named it E. So if you go to your calculator, and actually I've done this 3 times already, but I'll do it again. If you notice down here, on the left side, you've got an e to the x key. If you punch your e to the x key, it lets you put in e to any power. Well, I just want to know what e to the first power is. And there is, it's 2.718. Now it looks like it starts to repeat because you get 1828, 1828. You think, it's a repeating decimal. Yeah, then it goes off crazy again, and it never does repeat. So you can do e to any power you like and get its value out of your calculator. It's pre-programmed. Oh, which, by the way, somebody was trying this yesterday. They tried to hit the E down here on the keyboard. If you do that E, variable's not defined. It thinks it's a variable. It doesn't think it's the number E. It thinks it's a variable like using A for a variable, N for a variable. It does not recognize it as the number E. It's only the number E if you use the actual E to the xt. So be sure you use that one. The regular alphabet will not get you a right answer. And we'll actually be doing quite a bit with E here later. So there you go. E is the number 2.718. Why on earth would that be an important number? Who cares? But then again, why did anybody care about 3.14? Why do we care about pi? Circles. And you got to push stuff. You're the ancient Greeks. The ancient Greeks didn't work with 3.14. They had some fraction estimates. 22/7 is about the closest it gets to the actual value of pi. They just kept measuring, like they would measure around a circle and then compare it, the ratio to like the diameter, and every time they did it, no matter what size the circle, if you do a circle compared to the length of the diameter, this is around the circle's circumference, that's 2 pi r. The length of the diameter is 2 radiuses. If you cancel that, what are you left with? Pi. And they were doing it physically. They were measuring a big circle and then measuring the diameter, and measuring a little circle, measuring the diameter, and no matter whatever they did, the ratio turned out to be pi. And so they, of course, wanted to estimate exactly pi's value, and they came up with some fraction values. It wasn't until later we got more accurate values, the real decimal values of pi. But E is the same way. E is the nature number. Because, once again, particularly science people, more so than mathematicians even, start playing around with different things in science and measuring things that are happening in the natural world. If you start measuring, okay, how much did a plant grow on the first day, how much did the plant grow the next day, how much did the plant grow the next day, and they started graphing it, looking at it, they kept getting graphs that did something like that, which were exponential functions, and they kept finding out the base kept being E all the time. They keep seeing E show up in all these things in nature, if it's growing, or if it was things in nature that decay over time. They kept coming up with E being a base number on stuff. So E explains how a lot of things grow and decay in nature. Not everything uses E, but a lot of things grow based on E's value. That 2.718 just kept showing up. So then, of course, when Euler makes the connection to actually how you can define it as a formula, then whoa, now we've got something we can work with in math. And so E is actually super important. We use E for a lot of things. So, yeah, in my world, since I'm not a geometry teacher, I use E all the time. Particularly once we get up to calculus. E's a buddy. So E is something that you'll run across if you look at if they're studying how different bacteria multiplies, how fast it reproduces itself. You know, there's a new strain of influenza. How fast is that going to reproduce itself and grow? Or we can study how fast it spreads through the population. A lot of times, how fast that's growing, it's base E. It's an exponential function with E as the base. The last two classes haven't acted. Do you guys know that radioactive elements decay over time? Yeah, they have half-life that I talked to you guys about. I can't remember who I said what to. And usually, how fast they're decaying is usually it's got a base of E on this exponential function explaining how fast they decay. When we figure out how old bones and fossils are when they find them, there's a formula, it's actually on your formula sheet, that we use that tells us, we can use to figure out how old they are, and it's a base E formula. It just keeps showing up, so we really like E, the nature number. So Now, all I've asked you to do on those 4 problems on the bottom of the assignment, you were supposed to do with E, I just wanted you to get used to E. They have you punch in values of E in your calculator. So all you're doing is going to your calculator and punching in E to a value. They just have you experimenting with E a little bit. There's not a lot of work to do with E directly. So those aren't any major big deal. It's today, we're going to do a little with E. In next class, we're going to do a lot with E. So you'll be surprised. And in calculus, well, I can't tell you that yet because you haven't learned that yet. I'll say that at the end of class once you've learned it. All right. That's E. Woo! Yeah, doggy. Actually, that's a good place to stop.